Hey everyone, my name is Brady Mack. I'm a student at Rutgers University, and today I'll be talking about how I determined the canonical area of Genshin Impact's map. And so you might be wondering why I would do something like this and how. Well, at my high school, my high school was participating in the International Baccalaureate Diploma Program, and one of the courses under that is IB Mathematics, where it concludes with an assessment where all students have to create some sort of project, a paper that utilizes math to solve a real world problem. And so I was thinking about like what I could do for this project, and I'm someone who naturally likes video games a lot, so I started thinking about that. And luckily, that one game that I really enjoyed a lot around that time was Genshin Impact. And so Genshin Impact, just for those who don't know, is a game released in 2020. It's an anime styled open world action game, and it primarily takes place in a continent known as Teyvat. And so at the bottom right, you can see the map of Teyvat or at least the current state it was about 3 years ago. But one thing that's very common in video games is that they'll typically scale the size of the map to to a size that's much more manageable for players. So like because it would be inconvenient if players had to spend an entire 24 hours to run from like one end of the map to another. And so realistically, they make the map much smaller in game. And so this left me wondering about how large Teyvat would be if it were in real life, which will be the ended up being the focus of my project. And so, how did I go about this? So, there are some in game dialogue once that mentioned that between point A and point B on this map, as indicated by the stars you can see in the image, that the distance between these points is the X amount of distance. And so I used that to estimate that about 1 centimeter on this map is equivalent would be equivalent to 40 miles in real life, or about 64 kilometers. And so afterwards, my approach was to divide the map, as you can see in the image, into all of these different geometrical shapes, which would allow me to individually calculate each of their areas and then in the end sum it all together. This is a very informal method, mainly because it includes the water, which isn't really accurate. And the shapes are a little imprecisely drawn, so it won't be a very precise estimate, but for the sakes of the project, it was sufficient. And so we start with the most basic features, that being like the rectangles, the triangles, and the trapezoids. And so these are all just pretty basic, like stuff that you would learn in like elementary, middle school. For rectangles, you just multiply like the length and the width together. Triangles, you do that, but then divide it by two. And then trapezoids, you would sum up the two bases, the top and the bottom line, divide that by two, and then multiply by the height. And so all of these different tables are just little kind of like snapshots of the data I collected and all the calculations I would ultimately perform. But not everything in the map is just convenient enough to go by these basic shapes, because many of the sections ended up with these curve features as you can see in these images in the bottom left. And that can't be solved with just like algebra geometry. This is where we have to bring in some calculus and use integrals, which allow us to calculate the area under a curve. And so in the bottom right, you can see some of the calculations for that, and indeed they require the use of integrals. And so the results of this are that after we got the sum of all 31 components, we summed up all this. I summed up all of the totals to be approximately 105,888 square miles, or roughly 274,249 kilometers squared. So in real life, this would be comparable to the land masses of South Korea and Iceland, for example, some of these smaller countries, though that assumes we include the size given by the water in the map, which is ultimately unrealistic. And that's one of the many limitations of this project. As we mentioned, there's the water, there's the imprecise measurements with the method, and there's also the possibility that the scale that I created is inaccurate, since the dialogue that we base it off of may not necessarily be accurate or it's hard to interpret. And as I mentioned earlier, this project was done 3 years ago, and Genshin Impact's map is constantly growing. And so while it will be fun to do in the future an update to this project, but the map does look as it is in the bottom left here, which is roughly like you can see like triple the size. So it definitely would be a lot of work, but something I'd be interested in doing one day. And so thank you all for listening to me. I hope this was informative. And if there's any Genshin players listening, my profile's in the bottom right, and you can add me as a friend if you want to.